Good morning. I am Harsh Bhuvna. Today I'm going to tell you all what mathematical modeling in the ongoing pandemic is. First, let me begin by telling you what modeling is. Modeling is nothing but the abstraction of reality. It is a representation of a particular idea, phenomena, condition, or a situation. Now, what mathematical modeling is? Mathematical modeling is nothing but the framing of mathematical questions in mathematical terms. It is represented by variables, parameters, or functional norms. It is a simplified representation of the real world entity in equations. This is widely used in the fields of medicine, agriculture, management, social sciences, etc. Now, the importance of mathematical modeling. It helps us in answering specific questions. It helps us to understand the problem better. It gives us a thorough understanding of the system modeled. It prepares the way for a better design or control of a system. It is indispensable in many applications.
Good morning. My name is Annasa and I'm from class 9. Today I will be explaining limitations of mathematical modeling. Every model has its own practical limitations as these are created based on various scenarios which simplify the problem and work in certain situations. It is difficult to obtain fine-scale reliable data. For example, while we know the daily statistics of the newly infected and recovered people as well as the daily deaths, the reliable data about patients in non-critical and critical stages as well as hospital discharge statistics with reference to home quarantine or officially quarantined, etc. are not easily available. Based on these observations and available data in the public domain, a model is created. In this model, various variables are used: susceptible, S, E for exposed, I for infected, A for asymptomatic, R for recovered, H for hospitalized. SF stands for susceptible fever cases, SQ for susceptible quarantine cases, EQ for exposed quarantine cases, IQ for isolated quarantine cases, H for hospitalization cases.
Good morning. My name is Ishan Manik from class 9 and I'm going to explain the SIR model. This model is used to predict the trajectory of infectious diseases using compartments such as S for susceptible, I for infectious, R for recovered, and D for diseased. The Center for Disease Dynamics, Economics and Policy has created a model to predict infectious cases under different lockdown periods.
Now, this is a graph for the COVID-19 cases since January 2020. You all can see there have been a rise in the COVID cases and then a decrease and then again a rise and then decrease. Now, how to interpret these graphs? The graph in the last slide shows the rise of the COVID cases in India since February 2020, from 3 cases in February to more than 34 lakh cases on October 12th. This graph has a number that corresponds to each month since February. That number is the number of cases at that time. Now, in order to flatten this curve, the government has taken several steps. As you all know, there have been 4 phases of nationwide lockdown in India. The government has made sure that everyone wears a mask at all times. The government, as you all know, have started night curfews in our city, Mumbai, too. Thank you. I hope you've understood everything that you wanted to know about mathematical modeling.